Right, okay. We'll discuss the remaining part of the question. Question number 41. Can anyone tell me the equation? Quick. Very good, yes. No, you know, Pulahal, the equation for the force, right? F is equal to mass into acceleration, not gravitational, just acceleration. Now only we discuss, right? Now only we discuss. We'll do an example. We'll do an example here.
Sir, fourth one answer.
Third one. No, not third one. Wait. I'll explain. Don't worry. Okay. We'll move to the example. We'll say mass as 10 kilograms. Well, you can write along with me, right? Acceleration as 4 meter second minus 2. Okay, now we'll write the equation. Force is equal to mass into acceleration. That is the equation, right? Mass, that is 10 kilograms. And the acceleration, that is 4 ms minus 2. Answer will be 40 kilogram, this kilogram, and this ms minus 2. Pulahal, is there any other unit for the force? Is there any other unit for the force? Anyone? Is there any other units
Yes,
for
sir.
the what is the force, my dear?
Yes.
Newton. Very good, J1 and Zubair. Yes, very good. So answer will be 40 Newton. So now we have learned the equation and the unit. So equation will be force is equal to mass into acceleration. The units, there are two units right here. This one, that is called as fundamental international unit. That is called as fundamental international unit. And here fundamental unit, this one will be the standard international unit. The kilogram meter second minus 2, that is the fundamental unit. SI unit will be Newton, because question number 52, they are asking related to the standard unit. Okay, so at that time it will be needed. Okay, so question number 41, that is Newton. That is okay. 41 is okay. Now the answer for this question, listen here. I'm going to write the answer for this question by using another color pen. Okay, you know, force is equal to mass into acceleration. But here, all the equations that given in the question that are not related to the force, right? They are related to the acceleration. So answer will be like this. If you want to calculate the acceleration, what do you want to do, Bilal? You want to bring the mass here, right? Force divided by mass. Did you understand the concept? To calculate the acceleration, you want to bring the mass here. So acceleration will be F over m. That is, there are two answers, right? First one and second one. There are two answers. Okay. There are two answers. Pula, did you get the idea? Did you get the idea, Pula? Did you get the idea, Pula?
Yes, sir.
Fine. But Pula, can you put no in the chat box? Those who didn't get the idea. Can you put no in the chat box? Those who didn't get the idea. Akif, yes. Sir is yes, ma. Zubair, your answer is correct, ma. Your answer is correct. And Adiha. Aida. Okay, very good. Your answer is correct. And Atik done. And Zahira. Salam. Bishrul Hafi Hanan. You got the idea. Fine. So second also correct, right? Second, no. How the second one will be correct? Here, listen, that is M over F. F over M and M over F are different part, right? Nitish? Here, listen, here, M is here, right? You want to bring this M here, F over M, that is the answer. Sorry, Amahal. Nitish, did you get the idea? So can you explain, can you show the previous question? Shakib, which one are you asking, my dear? Can you tell me the number, Shakib? 32. Are you asking for the
Yes, sir.
32? Ah, okay. You can note down this one quickly. Don't take more time, maybe don't take more time. Fine. Nitish done. And right, okay. Now we'll move to the next part. We'll move to the next part. Well, Lati, I couldn't hear you.
Yeah.
32 done, 41 done. Okay. 47. Listen here, Pula, listen here. This is a phenomena or example related to the Newton first law, right? Listen here, Newton first law here. Already I explained that one, right? Here, a car and a box is moving, right? When the car stopped, the box is moving here. My question is this one, Pula. My question is this. Did anybody throws the box here? Did anybody throws the box here? Yes or no? Did anyone throw the box? No.
No.
Just the box is moving with the same velocity. For example, just say here we'll take like this. The box and the car is moving with the speed of 100 ms minus 1. And he also traveling with the speed of 100 ms minus 1. Then the car suddenly stopped. The box will be moving with the same 100 ms minus 1. You may remember, Newton said that until an unbalanced force is applied, you may have written the first law, right? Until you catch the box, until you apply the force, the box will be moving with the same velocity. Object in motion, the box is moving, right? The object in motion will move with the same velocity until you catch the box. Newton first law, right? Okay. So here, with the same idea, come to the bus and the human, bus and the passenger. Same like the box and the car, passenger and the bus is there, right? Bus will be traveling with the speed of 80 ms minus 1. And then what will happen, Palal? Bus will suddenly stop. Okay, fine. Bus got stopped, but not the passenger. So passenger will be moving forward until when? Until your head is going to be hit on the seat, or until your head is going to be hit on the bar in the bus. Am I right or wrong? Until your head or the body is going to be hit on the seat or the bar, you will be moving. Newton's first law. Until an unbalanced force is applied, the object in motion, the object which are moving, they will be moving with the same velocity. Newton's first law. Okay. Now come to the question. If the bus is traveling with the uniform velocity, stopped instantly by applying the brake, what will happen to the passenger? Move forward, move backward, become stationary with the bus. Passenger will be floating. What is the awesome idea? Forward or backward or floating? Which one?
Move backward.
No.
Forward.
Move forward.
Forward.
Forward. Bus paid the bus nikkuru. I don't know the name. Bint or something. The bus. Hey, just imagine that you are going in the car or you are going in the bus. Suddenly your car, the bus, what will happen? You will be jumping forward, right? You will be moving forward. So answer will be first one. Okay, and there are 24 messages. I don't know what are the messages that you have put. And Nitish, okay, very good. And Sheba first one, very good. Amra Mujib, okay, very good. Aida, very good. And Zubair, okay, done, very good. Akif, okay, done, very good. Swastika, done. Javon, okay, very good, very good. And Hafsha Al Kurish, done. Hudaybi, okay, move forward. Oh my god, there are more number of messages. Okay. I'm very sorry. Bin Trihan, did you get the idea, my dear? You said that we are moving backward. Is it clear now?
Yes.
Okay, fine. We'll move to the question number 52. Here they are asking regarding the moment of force. Okay, this is not related to the force. Sorry. Fine. Okay. Now, question number 56. Same idea. Same idea. Can anyone answer this question? Question number 56. What precaution? It is a general question. It is a general question. It is a general question. Just think, when the bus suddenly stopped, no, we will be jumping forward. So if we want to prevent that one, what do we want to do? We want driver and also the passenger, front and the back. Everyone want to put the seat belt here. If not, what will happen, Bulal? Here the driver will be coming outside of the vehicle, and those who are seated at the backward, what will happen? They will be moving forward, right? So everyone of you want to put the seat belt, but that is not possible because we have the seat belt only front seat. Anyways, the most suitable way, put wearing the seat belt for the passenger and also the driver. Now come to that paper, right? I have put that one into the group. You may have seen this one, right? Already we have discussed all these 7 concepts. Along with the 7 concept, we have discussed the Newton's laws, right? Question number 9, 15, 32, 41, 47, 52 and 56. You can cross check once again, right? You can cross check once again whether we have discussed all these questions. And there are 23 messages. Yalla, okay, yeah, okay. Mahal bin Trihan, first one that is wrong, okay? And Kulal, if the answer is correct, I didn't tell anything, okay? If the answer is wrong, I will be telling the mistake. Those who have, because all of you are sending the correct answer, I can't say very good, very good, very good, very good for each and everyone, okay? It is a very difficult task now. So those who have made the mistake, for them only I'm going to tell me an Akif, okay. And so, Javon, man, did you get the idea, my dear? Why your answer is wrong? Javon? Is it clear, Tanvi?
sir.
Okay. Now, and also velocity time graph, that is also we had discussed. Now, we are going to move for the 10th concept, that is displacement and the distance. Already we had discussed these velocity time graph questions. Distance and the displacement time graph. Okay. Listen here, Bulhar. Distance and the displacement. Look at the picture here. Look at the picture. Okay, here the cyclist start the journey from point A and he end the journey at the point B. We'll take like that. Okay. So he has traveled like these. Oh my God, I've different. So distance means the total length the object traveled. The total length, right? The total length. Total length he traveled. Just say 300 meters. That is the distance. Displacement means the length between the starting point and the ending point, and it must be a straight line. The length between the starting point and the ending point, and it must be a straight line. So that is called as displacement. We'll say 100 meters. That's all. Okay, now come to the question. Okay. Here you can see another example, right? Here A and B. So this will be the distance, the total length he traveled. Displacement means starting point, ending point, the length between the starting and the ending. That is called as displacement. That is 4 meters. Okay. Along with this idea, can you answer question number 13, Pulal? Can you answer the question number 13, Pulal? Yeah, very good. Yeah, Rakif, very good. Akif, very good. And Hafsha Al-Qursh. Hafsha. 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 Check the answer, my check the answer. And Nitish. Check the answer, my dear. Udebi, very good. Zubair, check the answer, my dear. No, yaar sonal will not like that. Okay. Sakib, yes, okay, done. Very good. And Aida. No ma. Check the answer. Bisrullah Hafi Hana, very good. And Raif, check the answer. Ahmad, check the answer, my dear. Zubair, okay, very good. Fazil, Take the answer, my dear. Neha, very good. Zainab, Zainab Shaham. Oh no. Take the answer, my dear. Hafsha Al-Kurish, okay, done. Nitish done. Shahid done. Moise done. Very good. Huda. Huda இன்னும் பழங்காலத்துக்கு எழுதிக்கிறீங்க, okay? Yeah, okay. We'll discuss the question, eh? We'll discuss the question. And Fazla. No. Again, once again wrong. Okay. It's okay, it's okay, it's okay. We'll discuss. Okay. Here the runner completed 2 rounds on a 200-meter track. Okay. We'll draw the track, okay? We'll draw the track. I will be using 2 color pen for the starting point and the ending point. Okay. So we'll start as starting point. Right, okay. So the the length of the track, that is 200 meters. And the ending point, this will be the ending point, okay? So we'll say he's running like this. 2 times, right? So 200. Once again you want to run, right? 200. So 200 plus 200, what will be the number, Pulhar? 200 plus 200, it will be 400. So totally he has traveled 400 meters. Total length he traveled, that is 400. But Pulhar, I want to ask you one thing. What is the starting point? This is a starting point. And what is the ending point? That is the ending point. So Pulhar, he has run 2 times. Okay, he have completed 2 times. It's okay. He has traveled 400 meters. Okay. I'm asking to calculate the displacement. What do you want to do? You want to check the starting point and the ending point. Starting and the ending both are same. He is starting the journey from the same point and he is ending the journey at the same point. So the displacement will be 0. Distance will be 400. So answer will be 400 and 0. Did you get the idea, Pulhar? Displacement means the length between the starting and the ending, right? Here the starting and the ending are same. So answer will be both one. Yeah, Raiha and Huda and Raif and Ahmad. Now your answer is correct. Nitish, okay, done. Sheba, check the answer, my dear. Fine. Bithun. Okay, done. Very good. Fine. We'll move to the question number 14. So 10 differ. Same idea. Same idea. Be careful. Be careful. That's all. Be careful when you're answering the question. That's all. If you in the exam paper they didn't give the picture for your as a support, I'm going to give you the picture, right? Okay. There's a lid like this. The lid of the bottle. Lid of the bottle is there like this. The ant is on the edge of the circular radius 7 centimeter from the point you stand. Okay. So radius is 7 centimeter. I'm going to draw the picture bigger, right? So the ant has started the journey from here. I will be using red color to show that the path here, right? He has traveled halfway, right here. He has traveled halfway. So now he is here. Starting point and the ending. Now what will be the answer, Bilal? They are asking the displacement, right? Starting point and the ending point. What is the distance between the starting and the ending? Yeah, most of you has sent me the answers. Manas
0 meter.
Pardon, 0 meters. Pardon. Zubair 14. Very good, very good. Okay. Akif, how it will be 22, my dear? How it be 22? You have, I think you have done the mathematics, right? Mahan, that is distance. Be careful, Akif. They are asking the displacement. Here, displacement means this one. Starting and the ending. What is the distance between starting and the ending? That is 14. Akif, 14. 7 plus 7. 14 centimeter, not 22. If you are putting the 2 pi r into 180 or through 360, then the answer will be wrong. Because they didn't ask the distance. If they are asking the distance, then only you want to do those 2 pi r calculations and all. But here, in this question, they are asking the displacement. Starting is here, ending is here, blah blah blah, done, all of them, 14 centimeters. No any doubts. Well, did you got the idea? Yeah, Huda, Ahmad, Raif, and Aida, and Akif. Okay, fine. And Muhammad Sifat, yeah, very good, very good. And Fazla Fadil, very good. Neha, very good. And Shabnam, sorry, Shaham. Okay, done. Uday be done. Afshal Kurish, done. Joseph, Nitish, done. Sheba, okay, fine. Okay. Now we'll move to the next question. Okay, that's all. Okay. Now scalar quantity and the vector quantity. Okay. Listen here, Pulaha. Listen here. Try to get the idea what is scalar quantity and what is vector quantity. Okay. This is 11th part. We have divided into 12 parts, right? So this is the 11th part. Okay. Scalar quantity and the vector quantity. It is very, very simple. Scalar quantity means just take the temperature. Just take the temperature. If I ask Akif, what is the temperature now? Then you will be telling like this, sir, 35 degrees Celsius or 32 degrees Celsius. You will be telling only the magnitude, only the value, only the worth of the temperature. 35 or 45 or 50 or 60 or 70 like that. And if I am asking the volume of the milk, then you will be telling 5 liters or 4 liters or 3 liters like that. And when asking the time, 3 o'clock, 4 o'clock, because it has the magnitude. Magnitude means it has a value. If I tell you to push this bus with 5 Newton, okay, 5 Newton, that is the magnitude. Okay, fine. But the next question that you will ask me like this, sir, in which direction that I want to push? Am I right or no? If I tell you to apply 5 Newton, okay, you will be moving, you will be going near to the bus and you will start to push with the 5 Newton force. But you will ask her in which direction that I want to push the bus. You will definitely you will ask that question, right? So the force has the magnitude and the direction. They have the both magnitude and the direction. They have both of them, magnitude and the direction. So these kind of quantities are called as vector. Vector have two horns, right? Vector quantity. They have two things. Magnitude also there. Magnitude means the worth, the value, 5 Newton, 10 Newton, 15 Newton, and the direction. They will have both of them, so they are considered as vector quantity. Now we'll write some example for the scalar quantity and for the vector quantity. You know, Pulahal, the time, the distance, speed, these are scalar quantity. For the vector quantity, displacement, and velocity, acceleration, and force. These are vector quantity. And for the scalar, you can say pressure, Pressure also scalar quantity. You will be confusing in the pressure part, okay? You may, some of you are thinking like that. So pressure is a vector quantity or a scalar quantity. Be careful, pressure is a scalar quantity. So now you may have written the example, right? Okay. Along with the example, can anyone tell me the answer? Which one have the magnitude? Which one have the magnitude and the direction? Which one?
Displacement.
Displacement. Very good. From the example itself, we can tell me the answer. Displacement, velocity, acceleration. First, for the scalar quantity, time, displacement, speed, and pressure. Akif, okay, done, very good. And Muiz. Muiz, Tammy, did you get the idea, my dear? Why the answer is wrong? For the question number 14, it will be third one. Okay. Now, we'll move to the question number 30. Question number 30. Shakib? Time scale quantity. Shakib, for the vector quantity, you can write the V like this and you can put a cap because they have the magnitude and also they have the direction. Fine, okay. Question number 37 now. Can anyone tell me the answer for this one? Pulahal, the velocity is a vector quantity. Normally we wrote that term, right? Speed is equal to scalar quantity. Okay, we'll write the equation for the velocity. Yeah? Can anyone tell Pulahal what is the equation for the velocity?
Displacement over time.
Very good. Displacement over time. For the speed, what is the equation? For the speed, what is the equation? Anyone?
Distance over time.
Very good. Distance over time. This equation will be needed for the part 2. You can check that one. In the paper itself, you can check that one. In the part 2 section, we have a question. In that part, we want to use all these equations. Okay. It will be needed. Okay, fine. We'll do an example and come to this part. We'll move to this question. We'll say object is moving from A to B. We'll take this one as 400 meters. And we'll take this one as 100 meters. And he took 10 seconds to move from A to B. He took how many seconds, Pulal? 10 seconds. Right? You know the equation for the velocity and the speed. Can you calculate the velocity and the speed and can you put it into the chat box, my dear? You know the equation, velocity is equal to displacement over time. You can calculate the value and you can put into the chat box. And you know the speed, that is equal to distance over time, right? So you can do the calculation and you can put it in the chat box. No, any answers? You know the equation, right? You know the equation. And I have written the equation. Just you want to substitute the values. That's all. Just you want to substitute the values. Yeah, Muiz, very good. And Raif, Raif, check the answer. Manasir, whether it is distance and displacement or Manasir means
Sir, what is the time, sir? Time.
what's the time? 10 seconds. 10 seconds. Here, I have given the time, right? 10 seconds. Very good, Azhar. Yeah, Muiz, okay. Mithun, Ahmed. Yeah, very good. And Raif, done. Ida, very good. Yes, very good. And Akif. Done. Okay. And Muhammad Sifat, okay, done. 10 and 40. Yeah, okay, then very good. Fine. Okay. And Hafsha, Hudaybi, Hafsha and Kaushal. Here discussion is not from the paper, just I gave, okay. And we have another question in the paper itself. The part 2 we'll discuss later, right? Okay. Now we'll put the values and we'll find the values. Eh? You know the displacement that is 100 meters. So we'll put 100 meters. Time that is 10 seconds. So answer will be 10 meter second minus 1 for the velocity. For the speed, you know, Pulahal, distance that is 400 meters. And you know the time that is 10 seconds. So answer will be 4 meter second. Oh, sorry, 40, sorry.
40,
40 ms minus 1. Right. Now, these are the equations and the substitution and the way to find the answer. Fine. Now, with this idea, come to this question. Question number 37. They are asking regarding the correct statement. You can make it wrong and you can find the correct answer.
Sir, fourth answer.
Fourth answer, very good. Yes. Pula, listen here, listen here. You know, speed is a vector quantity and the velocity is scalar quantity. That is wrong, right? Already we had discussed speed is scalar, velocity is vector. So that is wrong. Speed, S, that is scalar. Velocity, that is vector. That is a correct answer. But here, that is wrong. And second one, when the object falls down, velocity gradually decreases. Pula, you may remember we have explained this one in our last class. You may remember that. Here. You may remember this one. We have explained this one, right? When you are dropping an object, when you are putting an object, what will happen to the velocity, Pulahal? Velocity will increase by 10 by 10 by 10 by 10. You know, our free falling object, that was our sixth concept, right? So out of the 12 chapters, the sixth chapter was free falling object. So in that chapter we have discussed that one, right? When the object is falling down, the velocity will increase. So here in this question they have mentioned when an object falls down, velocity decreases. No, that is wrong. That is wrong. And third one, always the velocity of a moving object is constant. Just say when you are moving in the car, is the velocity is constant? No, right? If you want to accelerate the car, you will be pressing the accelerator and the velocity will start to increase. Am I right or wrong? You are going on a vehicle. The dog started to chase you. Suddenly, what will happen, Bulal? You will be accelerating your bike. So you will be increasing the velocity. Here they have mentioned that one. Always the velocity of the moving object is constant. No, that is wrong. Pachapala. So one and only option, that is fourth one. When the direction got changed, the velocity also will be changed, you know, because velocity is a vector quantity. It has the direction and the magnitude. Pulahal, just come to the fourth point. Just come to the fourth point. We'll say a ball is moving, right? A ball is moving with the velocity of 40 ms minus 1. And what will happen, Pulahal? It will be facing the wall and it will bounce back. It will be bouncing back. If I say the velocity in the both instances are same, whether whether my statement is correct or wrong. In instance 1 and instance 2, the velocity is same, whether it is correct or wrong. Whether the statement is correct or wrong. Anyone? The velocity. Wrong. Why it is wrong, my dear? Why the statement is why you are telling the velocity is not same? Because it has 40 and 40, right? How can you say it is wrong? Hafsha? Salanga.
Repeat the question, please.
Pardon?
Repeat the question, please.
I'm asking here. The ball is moving towards the wall in this direction, right? Okay, I'm going to erase this one and I'm going to show you the direction. Okay, I'm going to show you the direction by blue color. The ball is moving here like this, and then what happened, Kulahal? And then what happened? The ball moves to the wall and he bounced back. He bounced back with the velocity of 40 ms minus 1. My question is this. I am telling in both of the instances, when I am moving like this and when they are bouncing back, both of the instances, the velocity are same. That is my statement. I am asking whether it is correct or wrong. I am asking whether it is correct or wrong. Whether the velocity is same. Wrong.
Wrong.
Why the velocity are not same, my dear? Why?
Because the distance is
Because the direction got changed. Earlier, the ball was moving like this in toward east with the 40 ms minus 1. And the next time when they're bouncing back, they are moving with the 40 ms minus 1 in opposite direction. So the velocity is not same because they have opposite directions, right? So the both of the velocity are not same. Did you get the idea? Because when you are describing the velocity, you want to consider the magnitude and also the direction. When you are describing the velocity, you want to consider the velocity, the direction, and the magnitude. So just we can't say 40, 40, so both of them are same. No, the magnitude is same, 40, 40, fine. But the direction got changed. So here the velocity is not same in both of the instances. Okay, so now read the question, statement number 4. The magnitude and the direction are not changed when the object is in uniform velocity. If the object is in uniform velocity, the magnitude also will be not changed, and also the direction also will be not changed. If the direction changes, the velocity also will be changes. So that is the correct statement. Even if you didn't get the idea for the fourth one, definitely you can say first and second and third answer are wrong. Am I right or wrong? So according to that concept, we can say the fourth one is wrong. Pulahal, next to this question, draw this diagram. Next to this question, draw this diagram. Here we have a wall. Wall is there, right? And what happened, Pulahal? The ball is moving here. With 40 ms minus 1. And we'll say I will be using another color pen for that one, right? It is bouncing back with the same velocity, 40 ms minus 1. But the velocity is not same. Why? Because they change the direction. You can note down that one there. Don't take more time. And there are 29 here. Atik has sent me the answers. And Raha Mariam. Okay. And Heshma. Okay. And Jazahirin. Okay. Swastika. Hashmat. At the what time the class will be in? 10:15. Eh? Dinushan. Okay. Dinushan, yeah, very good. You have sent me the answers. I want to check the answers. Sorry, my dear. Very good. Eh? Yeah, Dinushan. Shakib Riaz. Okay. Done. Very good. And Nitish. Okay, wait down. Okay, no. Okay, no. Okay, fine. And another answer is there. Afsha Al Qurish. Fine. Fourth one is the answer. Very good. Okay. Now we'll move to the question number 40. Easy answer. Easy. Question number 46. Which of the following pair has a pair of vector quantity? They're asking the vector. Simple. Anyone?
That one.
Third one. Akif, very good. And Atik, very good. And another one is there. Swastika, very good. Yes, Swastika, very good. And Zubair Ahmed. Very good. Yes. and Minha, very good, and Huda, very good, Heshma, very good, and Dinushan and Hafsha Al-Kurish, very good. Drive done, very good. Okay. You know, Pulan, already we have written some example. You may remember right here the example for the scalar quantity and the vector quantity, displacement and the velocity. That is the answer. And the last one regarding the mass and the weight. Zubair, you may remember at that time I told you there is a question to explain the mass and the weight. So I will be explaining that one. Now, listen here, listen here. Regarding the mass and the weight. Okay. And I think in our second paper class or our third paper class, before the marathon series, we were discussing some question, right? Under the Newton's law of motion, the past paper question, we were discussing those kind of things, right? You may remember that one, right? And I have uploaded the video in the YouTube. You can check that one. So in that video, I have explained all the questions related to the past paper, related to this mass and weight. Okay, can check that one if you need more details. Okay, fine. Here, listen here. The mass. We'll say the mass of the object as 40 kilograms. Just imagine, Pulahar, if you are keeping a 40 kilogram of sugar in your head,
400 weight.
it will apply a amount of force in your head, right? When you are keeping that 40 kilogram weight, sorry, 40 kilograms of sugar bag in your shoulder, definitely they will apply a force. That force is called as weight. Here, this man, he is 40 kilogram. You know, Pulahal, that 40 kilogram man is applying a force on the earth, right? The earth is attracting that human with a certain amount of force, right? So that force, this force is called as weight of the object. The force that the earth attract. Okay? The force which the objects are attracted toward the earth. That is called as weight of the object. Now we'll calculate, okay, what will be the value. Okay, you know, already we have discussed the equation, right? Weight is equal to mass into gravitational acceleration. So mass 40 kilograms. Gravitational acceleration will be 10 ms minus 2. So answer will be 400 Newton. That's all. Okay. Now in this gap, you can write the definition for the weight. And you can write this definition. For the mass, I can say amount of substance. Sorry, amount of matter. Amount of matter.
Answer enna?
Yeah, weight. என்னடா ஆன்சர் என்னன்னு கேக்குறா? The force which the object attract, that is weight. ஏய் இவ்வளோ நேரம் பாடி பாடி சொல்லித்தாரே மேன் ஆத்தி. Got the idea, Atik? Did you get the idea? No. ஏய் ஸ்கூல்ல வச்சு நான் சொல்லி தந்தீங்க, எனக்கு நல்லா நினைவிக்கிறேன். ஸ்கூல்ல வச்சு அந்த பாசபக்க வழி செய்யற நேரம் அந்த 1/6 எல்லாம் போட்டு 3ல வார வெயிட் எல்லாம் நான் சொல்லி தந்தீங்க, நல்லா நினைவிக்கிறேன். Right. So answer will be weight, the force attracted by the earth.
Gravitation acceleration.
Yes, gravitational force, the weight, all of them are same. Yes, you can say gravitational force. Yeah, very good. Yaar sonnadhu? Hafsha. Hey, that is gravitational acceleration, man. Now I am telling regarding the gravitational force. Hey, both of them have difference, my dear. G, that is gravitational acceleration. Weight or gravitational force, both of them are different, my dear. Both of them are different thing. Hafsa, did you get the idea, my dear? Gravitational force is different part, gravitational acceleration different part. Weight is considered as a gravitational force. Okay, Atik and Hafsa. Hafsa, did you get the idea, my dear?
Yes, sir.
Are you sure?
Yes.
Okay. The Atik na Esratanaji Matakal paper telam, okay? Because he is a physical class student, but he is not doing that much well, you know. That's why I scold him. Okay, others, don't worry. Yeah? For you, I will never scold you guys. But for the Atik and all, I will definitely I will scold him because I have the rights for the scolding. But yeah. And fine, fine. And fine. We'll move to the next part. We'll move to the next part. The final touch. Ellam mudinji. We have completed all the part. Now we have come to the end. So in this part, we are going to write all the equations, and all the the formulas. Okay, fine. Come from the starting point, right? Okay, we'll start from the speed. The unit will be meter second. Sorry. We'll start on the distance. Distance is measured in meter. It will be needed, right? Definitely it will be coming in your exam. Displacement, that is also meter. Speed, that here we will be writing the equation. Here we will be writing the the units, and velocity equal to meter second minus 1. Acceleration equal to meter second minus 2. Which one, Vani? Sorry, Punal. Acceleration meter second minus 2, and force, that is Newton. The international unit, that is Newton, or kilogram meter second minus 2. And after the force, we will have the mass, that is measured in kilogram. Now earlier we had discussed that one, right? And the weight, that is measured in Newton. Weight, or you can say gravitational force. Sorry, Hafsha. You can say gravitational force. நாளை தூக்கிட்டு வருவாள் இல்லாட்டி இல்ல நீங்க வெயிட் தான் தந்தீங்க கிராவிடேஷனல் ஃபோர்ஸ் தரல நான் ஓகேனா. And momentum equal to momentum kilogram meter second minus 1. We will be writing the equation below, don't worry. Momentum, all these concepts were discussed earlier. We had divided into 12 parts, right? We had discussed all this momentum earlier. You may remember that one. Okay. And Punal, can you put like this? Can you put yes in the chat box? Those who have been attended all the classes, all the physics marathon series, all the physics session 1, 2, 3, 4, and 5. Can you put yes in the chat box, please? Yeah, okay. Zubair, okay, mashallah. Hafsha, 3 of you. Any others? Muiz, 4. Raha Mariam, 5. Atik, 6. Shakib, 7. Mashallah. And Fazla, you missed one. Okay. We use for the recording. Okay, mashallah. 8. Yeah, 9. 10 later. So those who have missed the paper class, it's okay. Recording is there. Please watch the recordings, okay? And Hishma, okay. Fine. And momentum. After the momentum, what is there? Momentum. Moment. Very good. Yes. Moment. That is equal to Newton meter. So these are the things that we have learned. Now we'll write the equations. Okay. First equation. for the velocity, the speed. Already we have written that one, it's okay. Speed equal to distance over time. Second one, for the velocity, displacement over time. Within that gap, you can note down all these things. Eh? Third one, the acceleration. Final velocity minus initial velocity over time. Fourth one, the weight. Already we have written the equation and we have done some questions, right? Mass into gravitational acceleration. And fifth one, for the moment, equal to mass into velocity. Sixth one, momentum. Force into perpendicular distance.
So acceleration.
Yeah, final velocity minus initial velocity over time taken. Here you can see final, initial. Okay, VF mean final velocity, VI mean initial velocity. Sorry, Afsha. YouTube channel name Infinite Science Academy, and I will be sharing the playlist. I will be putting into the group. Don't worry. Yeah, and momentum is equal to force into distance. Moment is equal. Oh, whoa, hey. Oh my God, very mistake note down. This is momentum, and this is moment. Sorry, I'm very really sorry. Oh my God, very or tapu tapino. Yes, sorry. Yeah. Huda, I have covered to the recording. Okay, fine, mashallah. Done. So, grade 10 first term and second term physics marathon has been officially completed. Not officially, not completed yet because we have the essay part. If we got MA, ஒரு முக்கியமானதை மறந்துடும். Yeah. Seventh one, F is equal to MA. Yeah. Zubair, very good. Yeah. Just check whether we have missed anything. Speed, velocity, acceleration, weight, momentum, and F is equal to MA. Momentum. Just check whether we have missed anything. Yeah, Pula, we want to discuss the part 2. Listen here. Subhanakallah bihamdika. No, not Subhanakallah bihamdika. Listen here. Pula, we have completed, sir, you didn't know anything about the moon. Sir, I didn't know anything. Oh. So we have completed all the theory part related to the physics for the grade 10 first term. So based on these ideas, try this question number 1, 2, 3 structure questions by yourself. Okay, it will be here this distance displacement today we had discussed, right? And question number 2, we may remember that we had discussed the displacement time graph and the velocity time graph. Here, can you relate that one here? They are asking what is the velocity time. Here they have given the velocity time graph for the uniform velocity, and they are asking you to draw the displacement time graph for the uniform velocity. You may remember, right? we have drawn the graph like this. 4 types of graph. Okay. So the same thing will be repeated again and again and again. All these things were discussed. All these things were discussed in our previous classes. So based on that idea, you can try all those part 2 questions. And if you have any doubts, without any hesitation, you can put it in the chat box. I will be explaining to you. Okay. So now in next class we will be starting the chemistry marathon, right? Chemistry marathon. For the grade 10 first term and the second term. Okay. So along, after completing the chemistry, we will be doing for the biology part, my dear. Okay. Okay with
Can
him.
you show
Oh, சொல்லுங்க
formulas? Can you show?
I couldn't hear. Can you louder?
Can you show the formulas?
I want to share the formulas. Okay. Hafsa. ஒரு கவலைக்கிடமான விஷயம் என்னண்டா, the equations are deleted. Okay. So those who have written the equation, can you raise your hand? நான் அவசரப்பட்டு அழிச்சிட்டேன். Okay. Yeah. Okay. Zubair, put a personal message, right? Put a message to my number. Take a picture and send it to me. Hafsha, I'm very sorry, my dear. I really forget. Okay, I'm very sorry. Yeah. Fine. Now we'll conclude the class. Subhanakallahumma bihamdika ashhadu an la ilaha illa. Before ending the class, I want to tell you one thing. Those who have joined the class, thank you so much. And you have some kind of need to learn, right? So for the 1.5 hour or near to the 1 hour and 50 minutes, okay, you are here in the class. So for that one, I want to thank you once again. And okay, we'll
Part 2.
yeah, part 2. Yes, you can do by yourself, and you can send me the answers. Okay. Subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. And assalamu alaikum wa rahmatullah, and good night. Have a nice day. And I won vanakkam and Hudaybiya. You are hating the biology marathon. Okay. Oh, Hafsa சொல்லுங்க என்ன சொன்னீங்க?
The formulas and
formula yes ma, நான் உங்களுக்கு அனுப்பிடுறேன் வாட்ஸ்அப்ல.
okay.
வாட்ஸ்அப்ல அனுப்பிடுறேன். ஓகே, வாட்ஸ்அப்ல அனுப்பிடுறேன். அந்த பொடி எனக்கு அனுப்பினதோட நான் உங்களுக்கு வாட்ஸ்அப்ல forward பண்ணி விட்டுறேன். ஓகே.
Sir.
Okay. We'll meet in our next class. Assalamu alaikum wa rahmatullah. Good night. Have a nice day. We'll meet in our next class.
Good night.
Sir.